Hello and welcome back. So now we're into the world of FinOps, arguably the most critical area to focus on to realize true cloud cost efficiency benefits. I don't know about you, but I've seen examples and advice on managing cloud costs. But here we've got a whole framework derived from practical usage at Perimeter X. I'm really looking forward to seeing this. So please take it away for us, Amir.
Hi, thank you. So, hi everyone. Thank you for joining me today. Like Jay said, we're going to talk a bit about how to take control over cloud costs. 2 minutes about myself. So, my name is Amir. I did the R&D at Perimeter X. Been around the block quite a while. And in the context of this story, I'm going to tell a bit about our journey. We're not a FinOps company, but I think like everyone working in the cloud and dealing with the cloud, you have to become a master of financials and the FinOps, and how it goes into play, what we did to help us to take control, manage, and some examples of how we did it. I will check the Q&A throughout it. If you have questions, pop them in. While virtual, I'll still try to do it as interactive if relevant if possible. So feel free to drop in questions. So with that, we'll start. A bit of an example. So our journey, like many startups, and it also comes to play to what's unique about how we looked at it. We started as a startup. We started small. We had like well, I'll tell a bit about what we do, and it will give context. So Perimeter X, we're a SaaS provider, a web security SaaS provider. And as part of that, we have instances all over the world, computing and doing analysis of data and giving value to customers, but in the context of cloud and FinOps. So we started small. We had one point of presence with a single server, 2 cores. Nobody remembers how much traffic we had. We started with GCP for various reasons, and in the story, I'm going to talk more about GCP. But everything I'm saying can be translated into each one of the cloud providers or any way else you're working and using. And it scaled up, and it scaled up quickly. 2 years in, 2 points of presence, 500 hosts, and sorry. 500 hosts, 2,000 cores, a lot of requests per second. 3 years in, a lot more hosts, and it didn't fit in. But looking today, over 30,000 servers, a lot more data, 400,000 requests. So really big network, and with that comes a big increase in costs over time. And that drove us over the years into how we manage the cloud costs, the FinOps, and how we work around it. So I think it's pretty obvious, but I will state what I think is obvious of why analyze your cloud cost. First of all, it translates into profit. If the cloud is what's costing you money in serving the customers, if we can control the costs and improve our operational efficiency, we'll just save more money and not just bear the cost. Improper cost controls can also be relevant when you're looking at the usage. When it's unexpected, it creates outages. If you don't manage correctly, you can just have a too complex system that's just harder to manage. When you're in control, the best you can. We're doing it twice a week. What we're calling the daily analysis for us is twice a week. But as much as you can help you control the cost and see where you're spending on and on what. And it can really help you drive business decisions, because if you're doing it right, you're actually impacting the business from something that might be way behind the scenes, but you can really drive business decisions and what to do better and what you should or shouldn't do across that. And obviously, you'll save money, which is good. So there is a lot of talk. I'm not going to spend a lot of time talking about what FinOps is and the shift left. I'll try to jump right in. Looking at it from three aspects. That technology is the first one, and I think one of the important ones. So it's things like labeling your entities. I'm going to give an example. It's making sure you have all the relevant data exported into some BI system where you can analyze and dive into it and see everything, and find a way to combine it with usage metrics, which sometimes are trivial and sometimes it's complicated, and it really depends on how you architect your system. But once you have this, you find yourself designing your system to have those usage metrics available so you can make more intelligent decisions. For example, say you're using a Redis servers. If you want to try and understand how a big Redis cluster costs, and how to break it down, if you're adding a specific analysis around that Redis cluster per different keys that you're putting in or querying, you can have a much better understanding of who's querying more, who's querying less, and which element is actually costing and increasing the cost of that Redis instance. And not necessarily saying that you should reduce the cost, but the actual visibility can give you better notion of what decisions you should be making. So the technology is definitely the first part of how you address that. The second is process, also very important. The tracking, looking for anomalies, looking for changes. Changes can go both ways. A change could be something going down and something going up. Even something going down can be a signal for something bad, because if someone has an example, I'd love to hear from you guys. But something going down can be an example of an instance that's actually a bug that you missed, and the building metrics can actually sometimes point you to things that you may have missed for other reasons. And last but not least is culture. It's educating, it's training people, the engineers. It's giving the visibility to everyone that's relevant for them to see the cost of what they're building and how it actually works in production, beyond the scope of I wrote a code and I deployed it. I don't care. There's a notion of I wrote the code, it's deployed to some Kubernetes cluster, and it's out there. No, give them the visibility into how much the cluster is costing before and after your deployment, how many things have changed, and it can help you understand, should you redesign, refactor, improve something either today or tomorrow, and make, like I said, cost part of the design and the optimization process, the ongoing process of what you do and how you operate. So with that concept of to shift left, both in the technology all the way to the culture and working with people, I'm going to add on that it's one of the things that we saw, which is a kind of a great risk, especially for hyper growth companies, especially startups. Because if you have a cloud infrastructure that is steady in cost and steady in size, you can set certain practices into how you manage it over time. But this as a bit of a fabricated example that I took from a few people that I've talked to. What you can see in some cases is if you don't manage the cost correctly, say you have a specific subsystem that is not linear in cost to usage, it's actually increasing in some exponential respect to usage. What you will actually have is the more usage you have in the system over time, the cost will grow faster and the profit will probably stay similar. And it should actually bring you to a state where if you don't manage it, you can find yourself that the actual growth is crashing you financially, because you don't know where the money is leaking from, where the leaky bucket is, and it's actually leaking faster and faster as you grow with usage or users in your instance. So that's really important to manage that. And the faster you expect the growth to be in your cloud or in the company, in the scope of months or years, the more you should look into FinOps and how you manage it and how you track that early on to avoid diving into it at a later stage where it's a crisis, and it could be a crisis. So, things that we looked at and some key pointers that are, I think, really relevant to watch for when you're analyzing that is, first of all, unused resources. Different ways to find them, but unused resources is definitely just a waste. And sometimes there are unused resources that are attached to components that you're using, say like a sidecar Docker running alongside a secondary Docker. But you don't need both of them. You actually need a few of the first and multiple of the second, but you're always deploying both of them together. And one is just completely underutilized. That's a good opportunity to go and refactor the system and reduce that first element and break them apart. Overcommitments and other undercommitments, that goes into once you hit a certain point of usage with your cloud provider, whichever it is, you can start trying to use benefits of committing to specific amounts of CPUs that are you're going to be using in different regions, memory, things like that. It's really good in order to control your cost and improve your margins just by getting better pricing on what you're actually paying for. Because once you commit, you get lower prices. But then these commits are for a year, for 2 years, for 3 years. If you don't do them wisely, you might find yourself in a place where on some areas you have overcommitted and you're not utilizing the resources that you committed to, and you're going to pay for them anyway. And on other areas, you're under commitments and you're actually leaving money on the table that you could have saved because you could have committed into more resources. So those are one of the things that you want to always look at. Those things that you committed to, are they being utilized? And if they're not, maybe you can shift workload between different components or elements. For example, if you have two compute regions, say one in Europe and one in the US, and you are under commitment in one and over commitment in the other, is there something that you can move between them and utilize better the CPUs that you're already paying for and just save money on that? Sometimes it's beneficial, sometimes it's not, because just, for example, maybe the cost of traffic will be more than what you save on the CPUs. So it's always in the fine print. It's never just a simple answer, but you need to look at those and analyze those. Um, Number four, really important, whatever you're building, it could be one element or multiple, try to get to some sense of price per unit. And then you can look at the relative price per unit over time of whatever it is you're building, um, and looking at how it behaves over time. Is it going up? Is it going down? How is it changing? It gives you some sense, and the relative here is very important because total cost will probably just increase as the usage increases. But if the relative price stays flat or decreasing, for example, it actually tells you a story where the system becomes more efficient. So even though you're spending more, you're actually spending less per usage or per customer, you're being more efficient. So it's really important to go into find your specific KPIs. For example, in our case, one of the products is serving requests, protecting requests. So we're looking at how much it costs us to protect 1 million requests, and looking at that metric over time. Is it going up? Is it going down? Is it changing? How is it changing between different regions, for example? Because sometimes the prices will vary. Um, and the last one to really look for, and we've found plenty of those, is bugs. Something that can really creep up into the system, a bug that is hidden, that is costing money, and sometimes the bug doesn't affect cost. And the only way to find it is by analyzing the cost and not accepting that it's just increasing or steady, really diving in. And this is where getting the engineers involved is so important. maybe there is something and some root cause of why is it costing as it's costing, and you can find something. And we found examples of that all the time. One example of a feature, we saw a steady increase in network traffic, and we found in a bug that sent duplicate messages sometimes. Now, there was nothing that happened because of those duplicate messages. There was no effect on the system itself, besides the fact that we just sent network data that shouldn't have been sent. Just removing that bug cut the network in half and reduced our costs. So, not accepting that the amount of network we're sending just didn't seem right. Diving into that, we found something that the only impact had just a decrease in cost on some specific metric. Um, okay, so, something which is, I think, very, very important is how do you want to construct your analysis of the costs in different elements? We are looking at three dimensions. Every dollar, we're looking at three dimensions of where it's going. And each of them tells you a different story with different opportunities. And all three are very important. The first one is the simplest one to create. You get it from your cloud vendor. That would be the SKU. How many dollars per memory, per CPU, per region, per network. Easy to get, easy to analyze. It's beneficial, but sometimes there is no story behind it. The second is a subsystem. Subsystem could be anything from a product all the way down to a specific microservice that you're running within your system. If you can understand how much each of those cost separately, and there are ways to do that. I'll give an example. You can really get a much better understanding of how the money is behaving, those KPIs of tracking the money is behaving, and where should you spend your time on. Because, for example, the SKU of the CPU usage could stay flat, but when you're looking at on subsystem level, you're seeing deviations of one going up and one going down, and it can tell you, it can point you in a direction of where to look and find something that you can work on. And the last one is per customer. The cost per customer of is basically how it's in using your subsystems and SKUs is important because first of all, it gives you very tangible information to work with your finance group products and how you can either save costs on a specific customer or just understand what it is that a specific customer is doing that's costing more than others, and it can give you again a new angle in understanding why the money is going a certain way. So all three of these dimensions are critical. The SKU is the one you get free from the system. Everything else you need to build. And I'm going to give some examples on how we build them. But the subsystem one and the customer one are things that you should strive to have as relevant information for you to analyze. But you need to build something in order to get that and to start becoming more intelligent into how you analyze costs within your system. Um, so the way we approached it, again using GCP, but can work with any environment you're working in. We started by exporting our billing data into BigQuery and creating custom dashboards. We use Data Studio for start, but very basic. Just make sure we have all the billing data in a table that an analyst can look at, and it's a lot of data. You get like sometimes 50,000 records a month of billing of lines of records per day per usage on only on the SKU part. The next is structuring and organizing those resources to get much more granular by project, by label, by folder, any way you're using your infrastructure. Labels is a very important one. It gives you a lot of granularity. I'll go into that again. Configuring policies, Hi there.
Hi, Amir. I think we might have lost you there for a moment. Are you back online with us now?
Chrome just restarted. Sorry, so I'm just bringing back the
Yeah.
slide, and
Okay.
apologies for that.
Thank you.
That was very, very strange. Don't know what happened there. Okay, all good now, right? Okay. Don't know what happened. Yes, where was I? Yeah, so I was going over configure policies, and the last is what I said, the culture. I want to jump ahead a bit to give you some more concrete examples. So how you work with that to try to get from data to value is, like I said, is both from the different vendors that you're using, and it's not only the cloud vendors. Say you're using a CDN provider, they sometimes have very granular logs of usage per service, per ID. Try to get that level of information, and then combine that with the total billing that you get, and you can again get to understand how much you're spending per instance or per customer, depending on how you use them, and business KPIs that you want to gather from your system and combine in to create those dashboards. I'll jump into the examples. I don't look well here. One of the things that we worked on and we invested a lot working with the teams is financial metrics is not trivial for the team to understand, for engineers to work with, understand. They're used to working with performance numbers, but actual dollars, sometimes harder to understand and to grasp and how to analyze them. And so we had to invest a lot of education, how to read the financial metrics, we did joint analysis sessions where someone, a FinOps analyst that understand how to read those metrics, works with the engineers to explain to them how to read the numbers, how to read the metrics, how can you use that to be better at reading those elements, just as you know how to read performance metrics of CPU usage and memory and everything, because it's very different when you're trying to understand why something costs as much as it costs compared to how much CPU that specific line of code I wrote is consuming. The subsystem-based analysis is an example of how you can do that using labeling within the cloud infrastructure. Say you have 3 machines to a specific microservice, label them in such a way, then when you have the exported data of the billing metrics, you also have that label attached to those records because it's part of the labeling of the server itself, the host, the CPU, all the components related to that. Aggregating that, you get to see the cost of the service and not the element. And an actual example that we had, you can see that looking at by SKU, the top graph, you can see that everything looks more or less stable. You don't see anything interesting if you're looking at these metrics. Looking at the subsystem level, we had a syncer service that synchronized with network different elements of the system, the double messages example I gave, and you can only see that when you're splitting the network into the different services using the network, not when you're actually looking at the network, because inter-region network had all the components sending traffic between them. Only when you split that specific element into the different subsystems that is using that specific SKU, can you actually see that once something was fixed, overall went down. And you can see that specifically went down more well-known a bit. You need that combination of the subsystem analysis with the SKU in order to get a much better control of how much you're spending. And if you'll take anything from the session and a few more examples and I'm going to cover is find the right labeling to use within your system, put it into your CI/CD process, your deployment processes, label everything, and then analyze from all angles, both the SKU, the subsystem, the combination of the two, and what's unlabeled, and try to get the unlabeled cost to as little as possible, because that will help you validate that you know how much each component in your system costs. So that's a very important takeaway to take out of all of this. And the labeling is very company specific, because how the subsystems are defined will vary with usage of every cloud provider. So an actual example of how we do that labeling within Google, we have a name, then we can create a label called billing component, and then we put some kind of value on that component, and using that labeling, when you export, you have all of that available for you in the BI system. Again, we use BigQuery, but it could be anything. That's not the critical one. And then you can have multiple of those, like to what region, to what department, to what team. Say you have multiple teams and multiple products, you can add a lot of those key values and then start labeling with all those labels, get a much granular data that you can analyze and track the cost. Really the basics of everything. So it's like step one, have the labels. Step two, your code analysis of the cost changes dramatically. It can really change design decisions because, as an example, we try to optimize preemptible usage while aligning our SLA. So we can't just switch to preemptibles, and we had to balance between the two. And how between preemptible hosts and regular hosts, and using these benchmarks of cost was actually a key element in how to balance and optimize the system between regular hosts and preemptible hosts. So we wanted to have, and we looked for the balance from cost and how to split between the two. And the way you can do that, looking for the glasses of cost, is obviously preemptibles cost less, but you can break the SLA. It gives you the bare minimum of how much commit should I have, going back to commitment. So I can commit to this amount of minimal CPUs, regular cores that I'm going to use, and everything on top of that that might be varying, I'm going to shift over to preemptibles. But in order to get the full benefit of the cost, I need to not just do the split, I also need to use the commitment around the bare minimum. So to make sure we're doing it correctly, but also going to the discussion of under commitments, if you're doing optimizations and that changes, you might start actually losing money, because if we committed to this number and we've optimized the system and while we're using less cores, we're actually going to pay for the same amount of cores. So going back into the cost, maybe you want to change the balance now between how many preemptibles and how many regular cores, because you're actually going to pay double of even if you're not using them. So always balance and analyze between the two. Not every time. It can sometimes tell you the story of why, even if you optimize, you're not seeing the full benefits of the cost out of that, because of things like how do you use commitments and how we manage the commitments around that. Usage metrics tends to be one of the more complicated ones that we faced. I have some example on how you can do that, but it's going into, if you have cost per subsystem, and that's an assumption of how we worked and over the years and learned. Once you have the cost per subsystem, if you can now bring in your own metrics of customer usage per subsystem, combining the two, you get a cost per customer. And that's an amazing data point that you can work with, but you can only get to that as a first step once you have the first two, having the data available and having it labeled per subsystem. So an example of that could be, say you're using a data store. So how many rows per customer are being stored, and you know the cost per the element. Now you can get a very simple answer of how much it costs you per customer to use that specific component. Once you aggregate that over all your components, could be documents in Elastic, could be requests per second in a microservice, anything that's more relevant for in your environment. Aggregating all of that, you get a cost per customer. And once you get a cost per customer, you go in from just managing cost to managing business decisions, and you can get gross margin per customer because you know how much they pay you, you know how much they cost, and now you can break down and look at how much, what's the gross margin that you're aiming for per customer. Is it good? Is it bad? Is it how you want to work with that? You can also get an ability to see gross margin per product or per feature, and that gives you a whole new angle of how to optimize, because optimization can sometimes come from new angles. It could be not from the performance of the system, it could be from changing the pricing, changing the way you look at a specific type of usage of a specific customer, and maybe adapting that, rate limiting something, gives you a whole new view of how to analyze and look at your data. And with that, let me see if there are questions. So I left some time for questions, but to summarize everything that we talked about, if you're looking at FinOps, one of those elements of latest editions, looking at the tool set of better with money, but the key of that is, first of all, having the data available. So just saying you do FinOps is not enough. You need to make sure you have the data and the right data available to the right people. You can't expect engineers to just get better if you don't give them the relevant information and train them on how to read that and how to use that. And we found that we need to do a lot of investment just around that. Processes that wrap around the processes that we are doing is both creating a timeline of cost projects, where it's not just the projects are around the cost, it's around projects that are happening and what do we expect their impact should be on cost. It could be up, it could be down, but gives you a much better predictability into how the cost is going to change over time. And when I'm saying cost, it's either total or the relative, because like I said, trying to get to a relative number is also very important, because the relative, as an engineering unit, you can really work with. Total costs can many times be impacted by how many customers you have and their usage. Relative cost is something you want to look at as an engineering team, as an operations team, and manage that and make sure that number is mostly under control and stable, or going down depending on what you're aiming for. And that will fluctuate, because oftentimes when you introduce a new feature, that relative cost will usually go up. It's not necessarily a bad thing. It's something that, if it's predictable, if it's anticipated, if it's a feature that product is going to charge money for, you can work with that and plan for that on the financial aspect. It's a point where the financial efficiency is very crucial to any organization's success, and it's combining the work between sometimes a team that's very far away from the business, like the DevOps or the operations, into heavily connect them into product, customers, the financial group within the company, because they're actually controlling a lot of budgets and they're managing it in many ways, like you manage overall budgets. Sometimes it's the same notion and education that you can draw or use the financial group within the company to train engineers into how to read the reports and look and analyze. Having an analyst dedicated for that always helps, and sometimes pays for itself, because they will find things within the system to optimize that will just save money off the table. It's very, and that goes into how crucial it is to which team is owning that and participating in that effort and trying to manage the cost. You want to have an owner. We said that the DevOps group is responsible for the FinOps efforts. It doesn't mean that they manage everything in terms of money. It means they own the project, they own the tracking, they own having all the data available and exposing that to all the engineering teams. And then if something misbehaves, they know to which engineering team to open a bug or a ticket to go and look into what happened. And that brings in everyone together into, okay, some cost increase. We see a spike of new 50 servers or a specific subsystem costing twice the money. We know where to go to. We know to which team, to which engineers to go ask to analyze. Just with sometimes with one challenge. Billing data usually comes in a delay between 3 to 5 days, depending on the vendors that you're using. So always remember that you're seeing it after the fact. So it also helps, if it's relevant, to add to that operational metrics that will be leading indicators. We're going to see an increase in costs, so maybe you can find that sooner. But if you haven't found that sooner, at least you're going to see that in a few more days and understand that something happened and tie it back to when in time something changed. The ad hoc, the things that you're getting off the shelf with billing visibility is very, very limited. And you have to expand on that if you're really a large scale cloud system and it's expected to grow. You have to expand that with labeling, smart labeling, exporting it to the BI system. As much as it's basic, I've talked to a lot of R&D leaders who haven't done that. That once they did it, it really opened their eyes into, okay, now we're starting to see what we actually have and what we're actually looking at, dashboards, graphs over time of the actual span between components. And really sometimes the most relevant dimensions aren't in those operational data of SKUs, memory, CPU, network. It's actually how the data is actually being used, how the processes are actually being used within the system, the traffic, the customer usage, specific APIs, specific subsystems. It tells a different story that you can go and analyze. I have time for questions.
Thank you very much indeed. Lots of really practical advice there to pick up on some of these themes. I mean, certainly for me, I'm interested to understand, if I've worked with a lot of teams who are just starting to kind of get their heads around the need for dedicated analysis on this. Is there any forums or reference works you'd recommend for people wanting to specialize on, how do I bring this kind of material together? You gave us some great practical advice. Where do you go to learn? How do we learn from others in this? Is there anything you'd reference for that?
Yeah, that's a really good question. So first of all, FinOps themselves have there's like a movement with a lot of information, a lot of data that I invite everyone who don't know that to jump into the DevOps movement website, and a lot of information you can gather from that. There are specific, like regional meetups that meet on that, but not as much from what I've seen.
Mm-hmm.
To be very honest, even when we were looking to add a FinOps analyst, it wasn't very
Yeah.
easy to hire one.
Sure.
You need even then you should hire just a good data analyst, but you need to train
Yes.
them on how to work with financial data, and it's something else. For some reason, for people, it's harder sometimes to work with large
Sure.
numbers of money,
Yep.
and a lot of ongoing experimentation. What I'm talking about is a process that
Sure.
took us, a year. It's not something that we just happened to do and it worked magically. It was
Of
iteration over
course.
iteration,
Yep.
how to do that better and educating.
Right.
Um, but as a base start, the DevOps movement has a lot of very good
Of course.
information in their sites.
Yeah. And I think there were some great pointers in your material that I think for people would be good drill down points from that point on. So yeah, we're into the last couple of minutes. I think that was it for the Q&A. We've got the next session starting at 5 minutes to the hour. And that's going to be on open telemetry with Dotan Horowitz. So for now, we'll leave it at that. Thank you again very much indeed, Amir. That was an excellent session. I would encourage everybody to follow those links and follow up on that advice. Thank you.